Hello, Honors Algebra, Mr. Lawrence with your flipped lesson here for, excuse me, for Friday, March 16th, for the weekend, that is. There's only one video, of course, because it is Friday. Kind of feels weird because I was out of day. Tomorrow is St. Patty's Day, but more importantly, Pi Day was 2 days ago, right? Okay, anyway, sorry for all you Irish people out there. No offense to Molly or anybody else who's probably really going to eat their corned beef and celebrate. All right. Let's see, here are the answers for the worksheet. Okay, there's 7 through 10 and 11 you can actually read, and I'll scroll a little bit. Okay, you go ahead and pause if you think I'm going too fast. All right, I just don't want to burn up too much of the video time, make it a really long video. Okay, so there are your answers. And hold on one moment. Okay, I'm getting ready to start the lesson. If you need to pause to go back and check any of those answers, you go right ahead. Let me put a couple things in here. Yes, I do have a graph out. I don't know if you realize this, but when you've been solving these quadratic equations, either by factoring or using the quadratic formula, you have been finding the zeros. What does that mean? Hold on a second there. I think I need a plus there, if I remember right. Finding the zeros, it means you're finding the place where this graph crosses the x-axis. This is really cool stuff. Look, I'm going to solve this one by factoring really quick. I know that I'm going to get 2 factors of 12 that subtract to get 4. Subtract to get positive 1. That would be a positive 4. And then a negative 3. And that would mean that x would equal negative 4 or x would equal positive 3, right? Those are the places on the x-axis where this graph will cross it. I can prove it to you, and I will in a minute. Let me solve it quickly by the quadratic equation. I'll do that in blue. A is 1, B is 1, C is negative 12. All right, so I'm going to do x equals negative 1 plus or minus the square root of 1 squared minus 4ac, and that's all over 2a. And simplifying that, I get x equals negative 1 plus or minus 1 plus 48. Whole thing is over 2. X is equal to negative 1 plus or minus square root of 49 over 2. And I'm running out of room. And then I'm going to get x equals negative 1 plus or minus 7 over 2. Negative 1 plus 7 is 6 over 2, which equals 3. Or negative 1 minus 7 is negative 8 over 2, which equals negative 4. And notice that's the same answer as I got when I did it by factoring. Okay? Now, I'm going to jump over to my graphing calculator here. And you see, right here, I have that equation, x squared plus x minus 12, right? And when I hit the graph, I get that image that you can see there. Now watch this. I'm going to trace it. Okay? And look at that. I'm right on the x-axis. And it looks like the x-coordinate is 2.9787234, and the y is negative 0.1484835. You know what? I'm going to zoom in there. I'm going to zoom in on that point and see. Okay, trace. And I'm going to look, I'm actually just a teeny bit below. Oh, now I'm a teeny bit above. Let me zoom in again. I want to show you something pretty cool here. I'll zoom in right there. I'll hit trace. I'll move so that, oh, look at that. Look at that. 2.99. That's pretty darn close to 3, isn't it? Let's see if I can get it to be 3 on the nose. I think I can. Trace. 2.9986. 3.001. Ooh, I'm very close. And at some point it should just jump to 3. But if I don't get it this time, I'll move on. Oh man, that's so close to 3. And notice when it's so close to 3, y is getting very close to 0, right? All right, let me go back to the way it normally looks. All right, and change my window down here. There we go. All right. So I bet you money that this is crossing here at the point 3, 0. Okay. And over here, it's crossing at the point -4, 0. How do I know that? Because I did all the work with the quadratic formula or factoring to find those zeros. Now, if I could find this lowest point of this parabola, yes, this is called a parabola. It's a U-shaped graph. It's called a parabola, a pronounced parabola. Okay, it shows up with quadratics. When you have the highest coefficient is 2, the highest exponent is 2, you're going to get a parabola, a parabolic graph. And I'll show you some demonstrations of how these occur in the real world, because they're all over the place. You actually have a parabola in your nose if you look at it. Anyway, all right, if we could find this lowest point here, it's called a vertex. If we could find the lowest point, we'd be able to plot the two zeros, the vertex, and draw our U-shaped graph. It's really easy to do because I've got ink layer upon ink layer here. All right, you know that the quadratic formula, by now you should know that x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, you know that the b squared minus 4ac, called the discriminant, b squared minus 4ac, is the discriminant, and that tells you how many solutions. In other words, it tells you where the parabola is going to cross the graph. Where the parabola is going to cross the graph. It tells you, not where, but how many times. It tells you if it's going to cross twice, once, or if it's a parabola that won't cross the graph, or won't cross the x-axis. All right? Now, you see this part of the formula here? This part of the formula here will tell us the x-coordinate of the vertex. The x-coordinate of the vertex is found by doing x equals -b divided by 2a. That will get you the x-coordinate. Now, I know Quinn is thinking, how am I going to get the y-coordinate? I'll bet you Quinn can tell you. That's right, Quinn. To get the y-coordinate, you're going to plug the x value into the equation. So let's try some of this stuff, and then we'll go back up and graph. My equation was y equals x squared plus x minus 12, right? And I'm going to come over here and go a equals 1, b equals 1, c equals -12. I'm not going to re-go through the quadratic formula. I do know that I solved it to get x equals -4 or x equals 3. I'm going to go up to my graph, and I'm going to plot a point where x equals -4, and another one where x is 3. Okay. Now, the vertex. To get the vertex, to find the vertex, I'm going to use, because it only gets me the x-coordinate of the vertex, x equals -b over 2a. Well, the negative of b is -1, 2a would be 2, so the x-coordinate of the vertex occurs at 1/2, and I'm going to go ahead and put a line in at x equals -1/2. Now, you should know how to do that by now. We've talked about horizontal and vertical lines. When we have an equation, x equals just a plain old number, we get a vertical line. And I'm making it a broken line because it's not part of my graph, but it is going to be a line of symmetry. Oops, there's no x in symmetry. All right, the line of symmetry. And it's x equals -1/2. All right, the vertex will be on that line, and every point except for the vertex will have a matching pair in equal distance from it, from the line of symmetry. Equal partner. Look at this. How far away, I'm going to call this point A and this one point B. How far is point A from the line of symmetry? Well, I think it's 3.5 units away, right? 1, 2, 3, and then a half. How far is point B? 1, 2, 3.5. It's 3.5 units also. Okay, now those aren't actually, those little green lines aren't part of the graph, so I'm going to take them out of there so they don't confuse you. All right, and I am going to do the math to find the y-coordinate of the vertex. So I know that x is 1/2, So I'm going to, negative 1/2, I'm going to do y equals, let me see here, negative 1/2 squared plus negative 1/2, and again, these parentheses are going to become very important here, and that'll be minus 12, right? I think I got that right. Yeah, there we go. All right, this will turn into y equals 1/4 minus 1/2 minus 12. Now, a fourth minus a half should be negative 1/4, right? Because this one is half of that. So I'm going to get a negative 1/4 minus 12, which equals negative 12 and 1/4, or negative 12 1/4. So I go up to my graph on the line of symmetry, and I go down 12 1/4. And I'm going to do the point of symmetry in red so it stands out. This is 10, 11, 12 1/4 would be approximately there. All right, so that would be the point 0. Oh, no, not 0. That would be the point negative 1/2, negative 12 1/4. And now that I've done that, my parabola just looks like this. I draw part of the u here, and then I draw the other part of the u here. Okay, this is not a V, not a V. It's not a V. It's curved at the bottom. Okay, and these never go vertical. They will climb steeper and steeper, but they will never go vertical. So you always get some type of U-shaped graph. All right, let's try another one. I know this video is going a little bit longer, but let's try another one. All right, let's do, now I'm picking pretty ones so that they're easy to graph. This is an easy one to factor, but I'm going to go ahead and use the quadratic formula on it. So let me see here. A equals 1, B equals 6, C equals 9, right? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, then x is going to equals negative 6 plus or minus the square root of 0. Yeah, this is 36. That's negative 36. You get 0. And that's over 2. So therefore, x is going to equal negative 3. Remember, my discriminant came out to be 0. I only have one solution. Well, let me get that point graphed. X equals negative 3. All right, remember, y is 0. So I need some graph paper here. There we go. I'm going to make it a little bit bigger. So x equals, what did I say, negative 3? Yes, I did. Negative 3. So the 0 in this case is actually going to end up being the vertex. This is actually going to be the vertex because it's the 0. There's only one 0, and it's sitting right on the x-axis. So in this case, it's the vertex. So I'm going to draw my line of symmetry in, and I already know the x-coordinate of my vertex is negative 3. And that's the line of symmetry, x equals negative 3. Now I'm going to need two other points, and I'm going to go to a t-table on this one. I'm going to go to a t-table, all right? My equation was x squared plus 6x plus 9, right? I think that's what it was. Yeah. Okay, so now I'm going to work really smart. I'm going to put 0 in for x. And when I do that, y is going to be 9. Okay, so I'm going to plot the point 0, 9. So that'll be way up here. There's the point 0, 9. Now watch this. Because of symmetry, watch what I'm going to do here. I'm going to count. See, I'm going to do so little math other than counting. Like I'm going to do kindergarten level math. I'm going to count over 3 and then up 9. Because of symmetry, there has to be another point over 3 to the left, 1, 2, 3, and then up 9. Now you understand that these purple segments are not part of my graph. I'm doing them to demonstrate how I'm getting these points. There has to be another point there. If I really wanted to, I could put negative 6 in to my equation. All right, that would get me 36 minus 36 plus 9. Oh, Andrew, did you catch it? I'm sure you did. And then Brendan gets jealous that you catch the mistakes, so then he tries to catch them, not realizing that they're really annoying me. Anyway, there we go. So I'm going to get rid of these purple things because they are not a part of the graph. It was just to demonstrate symmetry. Okay? And then I can draw my parabola. And there you go. It's that simple. All right, it's gone about 15 minutes now. The first minute was the answer key, so I won't count that. Don't hold that against me. But it looks like it's going to be about a 15-minute video, not counting that part. All right, so you're going to get some practice with this on Monday and Tuesday. All right, remember to work on those quizzes I gave back to you because you are having a second quiz on Tuesday. But those of you that don't prepare, you're going to be out of luck. Your grade's going to get worse. All right, Mr. Lawrence signing off. Good night, everybody.